Okay, let's do an application problem of that. I think this is, I believe this is your number 5. An aircraft at sea, it's here, spotted by two observers, A and B here, who they're going to be 1,400 feet apart. So I can go ahead and throw that in there, 1,400 feet apart. As the airplane passes over the line joining them, each observer takes a sighting of the angle of elevation to the plane. So this is observer A. The angle of elevation is going to be alpha there, which alpha is what we're going to label this 45 degrees. And observer B, angle of elevation is going to be beta, which is 40 degrees. How high is the airplane? So angle ADC and also triangle BDC, they're both right triangles. So our goal, first of all, is to find H. Okay, since they're right triangles, we could say sine of alpha is opposite over hypotenuse, right? So sine of alpha is H over B. Or we could even say sine of beta is H over A. Or we can either do H is equal to B times the sine of alpha, right, by our definition before, or we can either do H is equal to A sine of beta. So let's just go ahead and do this to calculate. Okay, so before we can do this, we need to find a value for either A or B in this triangle. So let's find some of our unknown values. First of all, A is 45, B is 40. Can we go ahead and solve for our gamma? Let's get our angle out of the way. So let's do that one. Okay, so one of the things we can solve for, and it's usually one of the easier things we start with, is our gamma. So we have 95. So now we have all of these angles. The next thing is we need a side. Particularly to find H, we need side B. So we can go ahead and use that law of sine. So let's do sine of beta over B is equal to, we only know side C. Side C is 1,400. We don't know this one or this one. So we're going to be working with sine of gamma over side C. Okay, let's go ahead and do the calculations for this. Okay, just check that you're setting these up right. We know side C is 1,400 and we just found gamma to be 95, so we're ready to cross multiply and solve here. Okay, so we have B is approximately 903.34 feet. Now we can, first of all, let's go back. How high is the airplane? So ultimately our goal is to find what? H. Now when we started with H, we knew we needed B times the sine of 45 degrees. We didn't know B, so then we had to find our missing angle, and then we used law of sines. Well, now that we have B, we can go ahead and see if we can find H at this point. So let's start. H equals B times the sine of 45 degrees. B we just found to be 903.34 times the sine of 45 degrees. So what's that mean? Our height is approximately, so if we plug that information in and you calculate this times the sine of 45, you should get approximately 638.76 feet. And that's all that it was asking for in this case.